session. So looking forward to that. Or over to you.
Okay, thank you, Sarah, and thank you all for inviting me. I'm very excited to be here. My name is Olduek. I'm currently an assistant professor at the Faculty of Health Sciences in Ben-Gurion University, and also adjunct assistant professor in the Yale School of Medicine. And I'm going to talk about one of the researches I did during my postdoc at Yale with Professor Harpersworth and colleagues. I invite everyone to kind of ask questions during and try to make it as interactive as possible. Just kind of to briefly mention what's post-traumatic stress disorder in case we have some trainees or people who are not really familiar with that. Following exposure to life-threatening events, which DSM calls criteria A. Some people develop different symptoms that DSM-5 clusters into 4 main symptoms of intrusions, some like flashbacks or repetitive unwanted memories, avoidance, such as avoiding things that reminds me of the event or thoughts, alterations in mood and cognition, on top of feeling more depressed, also things that are associated with the way I perceive other people and the world. And lastly, alterations in arousal and reactivity, basically hypervigilance, startle reaction, etc. PTSD is suggested to be between 6 to 10% lifetime prevalence. It depends on the study. And we have a bunch of trauma-focused psychotherapies that are currently the treatment of choice. There is no medicine for PTSD yet, with prolonged exposure is, I think, the most known one. And also cognitive processing therapy. We also have the EMDR and others that you probably are familiar with. I will focus on prolonged exposure because this randomized control trial was kind of based on a variation of that specific treatment. Prolonged exposure is very effective when working, but it's very hard to complete. Usually we're talking about 12 to 16 weekly sessions. So it takes a while, and in those sessions, people are kind of exposed and are reminded of their traumatic event, which is something that is very hard to endure for such a long period of time. That's why we have approximately 50% dropout rates. And even if I take an overview of the trauma-focused psychotherapies, we see around 50% remission. And in medication, with first-line medication for PTSD are basically antidepressants and mostly SSRIs or SNRIs. And we're talking about approximately 30% remission. So it's clear that we need something to help the others that we can't reach now clinically. Before I'm going to talk about our the way we try to kind of suggest some novel intervention, I want to talk a bit about the idea behind exposure and how it's rooted in the way we process our memories. And if you think about the time in which we encode a memory, so at the beginning, once we encode the memory is quite labile. So we can alter it relatively easily. But with time, the memory gets consolidated and it's more stable and harder to alter. But studies in the past 20 years or so suggested that once the memory is reactivated, we open a window, a shorter one, but a window in which the memory is again labile, and we can alter it before it gets reconsolidated, basically in a method that we'll call later on post-retrieval extinction. So to kind of give the basic idea behind those studies and how we perceived our intervention as well, let's start with a very simple kind of aversive learning classic task. in which you can think about these two rectangles, the green one and the blue one that I'm presenting to a participant. With the green one, sometimes it's paired with electric shock that is very unpleasant to the person. And if I'll measure the level of stress or inconvenience across time, I'll see that soon enough, the green rectangle, the participant will be more stressed when he or she are encountered with that. But if I continue to present those two rectangles for a few more times, but without the shock now, what we will see is some kind of a decline in the stress reaction, which we will call extinction. So we basically extinct this aversive learning. And at the beginning, when scientists found that, they were quite happy to see how we can kind of erase almost fear memories. But soon enough, people found that this fearful memory is not actually erased. Rather, it's probably generates some competition with the old fear memory. And the way they discovered it is if you wait, so across time, or if you give the participant a shock without the green rectangle, for example, suddenly the stress reaction comes back. It gets reinstated. And later on, we now know, and it's a very simplistic kind of diagram of what we assume that happens, is we know that the prefrontal cortex is inhibiting mostly the amygdala reaction to the stressful stimuli. And that's how the extinction probably works. The thing is, sometimes it doesn't, it's unable to inhibit this reaction, and that's why we see those reinstatement of fear. About 10 years ago, Schiller et al. Showed that if you do the same task, but now instead of presenting the green rectangle over and over without the shock, you start by reminding the participants this previously fearful stimulus. Wait for a few minutes and then start this extinction period. What you'll see is basically the same thing. The level of stress declines with more and more presentations of that stimulus without the shock period. But what changes is that following time, or when shock is introduced, the stress reaction doesn't come back. And this is what they call post-retrieval extinction. So basically you retrieve the, let's say, traumatic memory, and then you start the extinction. So you open this window in which the memory is labile, and you are able to alter the original memory. And in a later paper, the same group showed that what happens in the brain once this stimulus is being introduced is what you see is a decline in the amygdala activation to the previously stressful stimulus. So now, without the involvement of the prefrontal cortex, you see a change in the kind of original memory. So this is how we try to conceptualize our intervention as well. The idea was to recall the traumatic events and reprocess it. So to focus on this, to open a window of reconsolidation in which we retrieve the traumatic events and move it from stable to labile state, and then we start to process it. And once it's reconsolidated, it's reconsolidated in an altered form. We wanted to, in order to try to tackle the high dropout rate, we thought that it would be good to try and run very intense masked exposure therapy, of exposure and reprocess therapy. We thought that the challenge of learning in such a short period of time might be a bit, well, this might be a bit challenging for a person to be able to actually alter the original memory in such a short period of time. So we looked for something to enhance the ability of learning. And we, of course, thought that using ketamine will help us achieve that. And I know most of you are familiar with ketamine, probably more than I. So I'll just say a few words. It's an NMDA receptor antagonist, of course. And while it has an acute phase, following this acute phase, so a few hours later and up to 7 days, it was found that ketamine, via a cascade of events, promotes neurogenesis, synaptogenesis, cell proliferation, and some kind of reorganization of the connections of the brain. So we thought that if we will harness the power of ketamine during this time window, we will be able to establish better results for our 4-day exposure and reprocessing therapy. So that's what we basically did. We screened more than 100 participants. Eventually, 27 were screened in and followed up. Following the screening that used, of course, the state-of-the-art interview methods, we had a scripting session in which I would soon enough show you an example of that script. But the basic idea is that a clinical psychologist is sitting with the participant and asks them to tell them about their traumatic story, about a sad story from their lives, and about some story that is more relaxed or neutral in this case. And also, after every story, we ask them to kind of circle a bunch of physical reactions that they felt during those stories. We take this information and we build scripts that should be narrated for 2 minutes as an audio clip. And the script starts low and ends up on the hotspot, on the worst situation in the traumatic event. So unlike regular psychotherapy, in which we start safe and end relatively safe, here the script is basically, the idea is to create a provocation. So we'll be able to understand what's going on in the brain while listening to the script. And again, I'll soon show you an example. Later on, before the week begins, the psychologist who runs the psychotherapy sessions meets with the participants. Well, first to get some information about life history, of course, create some kind of a rapport, and if time permits, build an exposure hierarchy session, all of which takes between 2 to 3 hours. Monday morning, we meet at the magnet, and basically the participant is following DTI, and MRI is then being played the 3 scripts that we kind of talked about during the scripting session. We play them a few times for each patient, and we do it while he or she are in the magnet. So basically, we have the brain activation during listening to the stories. Following this provocation session, patients undergo infusion of either ketamine, 0.5 milligram per kilogram for 40 minutes, or midazolam. Midazolam is a benzodiazepine with a relatively short half-time, and we wanted the participants to be as blind as possible to the research conditions. So we thought that administering placebo will not be, they won't be blind enough. So we figured out that using midazolam, which was also used in previous studies around ketamine and PTSD, will be a relatively good candidate. And then from Tuesday till Friday, we are doing this exposure and reprocessing therapy and in vivo exposures. Again, the therapy sessions take between 90 minutes to 2 hours, I would say. In these sessions, we generally follow the prolonged exposure protocol, but with the idea in mind that we want to retrieve the memory as best as possible and then process it while it's in altered form. Next week, we run the same, basically the same procedure, but without the infusion. So now we also get DTI information and fMRI information while listening to the traumatic, sad and neutral stories, but now it's after the treatment. And we also do a 30 days follow-up. And the original plan was to do 90 days follow-up as well, but unfortunately, COVID broke and MRI center was shut down for a while. So we didn't have enough participants in the magnet for the 90 days follow-ups. But we kind of send them online forms to fill in. So we do have some symptomatic information about that. So I'll just say before I move to a scripting example, I'm going to show you a 2-minute example with a narrator, so with an audio as well. It's a bit triggering, so hold on. So now let's ask the first very simple question. Did this intervention work? So did it improve symptoms of PTSD? And simple answer is that it seems so. It seems that most people were dramatically improved from before to after treatment. You can see, and I kind of, the dashed red line is like the PCL5 cutoff, which is again not a diagnosis because unfortunately in the follow-up sessions we didn't do CUPS. But you can see that the encouraging thing is that even in the follow-up sessions, participants were kept below this line. So basically they kept their symptoms at the same level as, or even better as at the end of the treatment. When I compare the group who received ketamine to the group who received midazolam, we don't see any difference in the symptoms between both. We basically both improved and quite similarly. But we were actually focused, and we can discuss what we think about that and why did this happen, but we were actually more interested in the brain mechanism behind that. And as I briefly described before, our main hypothesis was that ketamine will enhance this post-retrieval extinction, what I call here unlearning for simplification matters, which is lowering the amygdala activation and show some difference in the brain activity. So this is the hypothesis that we had about ketamine. We expect to see lower amygdala activation in response to this traumatic script without the intervention of the prefrontal cortex, basically. And if what we saw is basically some kind of result of an extinction, we would expect to see a dramatic increase in the prefrontal activation and some increase in the connectivity between the prefrontal cortex and the amygdala. So to inhibit amygdala's reaction, right? So taking those two possible hypotheses, we looked at the difference between we compared the difference in brain activation between the traumatic script to a neutral script. On each of those regions of interest, the amygdala, hippocampus, and ventromedial prefrontal cortex, and let's see what we have. So in the amygdala, what we see is, so you have, if you want, the simple graph is this one. You see my pointer, right? Now I look for someone to nod. So if you see before treatment, you see almost no difference between the groups, and you see some decline following treatment that stays basically the same at the 30 days follow-up. And you see that in the ketamine group, but in the midazolam group, you actually see some increase in amygdala activation. And this difference between the groups following treatment and in 30 days is basically significant. So in ketamine, we see a lowering of amygdala activation in response to the traumatic script following treatment and in the follow-up session, while in midazolam, we don't see that. We also looked at the hippocampus as it's a very important region involving contextual and other kinds of memories, of course. And in the hippocampus, the picture is a bit more complicated. What we found is that while following treatment, we see some decline in hippocampal activation to the traumatic event compared to the group who received midazolam. This decline does not hold, so it's transient, and in the 30 days follow-up, the groups are basically the same in the level of activation of the hippocampus. And we can think about that. So we have two options. Maybe this result is just noise, but the other possible option is that that might be some transient mechanism of change that we catched at the end of the treatment, but later on was not apparent anymore because the change already happened. And when we look at the ventromedial prefrontal cortex, we see basically no difference between the groups before, after, and in 30 days follow-up. So to sum up the activation element, we see basically that the ketamine group showed the lowering of the amygdala activation with no VMDFC involvement, which is, of course, in line with our main hypothesis. We also looked at the amygdala and hippocampus functional connectivity, and we again saw a similar picture to the one we saw in the hippocampus activation as well. So some transient change following treatment that does not hold for the 30 days follow-up. Again, this might suggest some mechanism of change that involves the hippocampus, maybe altering some activation of the amygdala that holds in the amygdala later on. Lastly, we used also DTI in order to kind of look for maybe structural changes in the connectivity. Here we can't focus directly on amygdala and hippocampus and ventromedial prefrontal cortex, but what we took is the uncinate fasciculus, which is a bundle of white matter that goes approximately from the limbic system to the prefrontal cortex. And we see a very similar picture here with ketamine altering the white matter integrity compared to the midazolam in both the left and the right UNC. So you can see that the group receiving ketamine showed the lower white matter integrity following treatment that stays basically stable in the follow-up session as well. So I'll try to sum up and then open up the discussion. Basically, I would say that we found that the 4 days exposure and reprocessing therapy works. We didn't see any symptomatic differences between the group receiving ketamine and midazolam at the first day of intervention. But we do see that ketamine and midazolam has different mechanisms of change, with ketamine showing something that's more similar to the post-retrieval extinction that I was talking about. And the midazolam doesn't show a clear mechanism, so it's not very in line with the extinction hypothesis that was suggested, but rather something in between. And in the ketamine, we also show that we show white matter integrity becomes lower, and that might be associated with the reorganization of synapses. And in the paper itself, we discuss it a bit and compare it to some similar findings that were found on animal studies following ketamine. I'll briefly mention that, I don't know if you know, it takes a village to raise a clinical trial. And it took many people who participated in that. And I want to thank first and foremost to Professor Ilan Harpaz-Rotem, the PI, and Professor Ifat Levin, who helped with neuroimaging analysis, and of course Professor John Crystal, who helped us and guided us through the study. Just to give you a very brief idea of what it takes, we're talking about approximately 3-4 hours of screening, including medical screening and clinical psychologists, then 2-3 hours of scripting session. And each of those sessions of the MRI sessions are taking between 2 to 4 hours. The first session is quite long. And on top of that, 2 hours of prolonged exposure sessions every 4 days. So we are way over 30 hours per participant. So yeah, it takes a lot. Thank you, and I'm open for questions now.
Thank you. Thank you very much for terrific presentation and terrific work. I really, encourage everybody, if you have any questions, just to write them in the chat, or you can just raise your hand. And, if you feel brave enough to ask the question in person. Well, maybe like the audience is gathering some ideas after this very rich presentation, I may kick off with some question on my own, if that's all right. So from what I was reading, or like you decided to start the therapy at 24 hours, right? 24 hours after the infusion. And I was wondering if you have any comment on the timing that you picked about this therapy. Why 24 hours, not why after the infusion, or as somebody may even do like during the infusion?
Yeah, thanks. So that's a really good question, and we actually, Ilan just recently received a grant for the basically second phase of that study, in which we add another infusion during those sessions, so during the week, and we discussed the timing of the intervention quite extensively. I don't have a finite answer. But I would say that following the infusion, it takes the participants a while to recover. So participants who receive ketamine, it takes them around an hour, maybe a bit more, to fully recover. And we then we have a psychiatrist to assess them before they are released from our hands. So exactly during the infusion, I guess they won't be cooperative, because they will be kind of less attentive to our discussions or our words. Some of them are more dissociative in those situations. Mechanistic wise, as much as I understand it, in the first few hours or minutes to few hours, the reaction of ketamine is a bit different than the one that comes on the later stage. So we tried to kind of harness the second stage of the effect of ketamine, in which it promotes the neurogenesis, etc. I would say that if we had no limits, probably a few hours later it will be better than 24 hours, but it was hard to actually do something like that, because if you think about it, they wake up 6:30 in the morning, they're in the magnets, they undergo this very extensive treatment, etc., and then it takes them time to recover. So they are quite exhausted by the end of this, like 12, 1 o'clock, and they are quite exhausted. So it will be interesting to try to talk with them. But we're going to do something like that in this second phase.
Well, we will be looking forward to that as well then. I think we have a couple of questions in the chat. So one is from Tiago. Tiago, I don't know if you want to read it or like ask the question yourself, or if you should just read it out loud.
Hi.
Yeah, go ahead.
Just asking that midazolam has amnesic properties. It usually mess with the memory when you use it during the period you're using. So I just was just thinking that when you open the memory, and if you throw midazolam, you may not be able to close the same memory again. And that may be one co-founder, something that mess up with the results. What do you think about it?
I think you're right, generally speaking, and this is one of the limitations of I can talk much more than 20 minutes about the limitations of the study, I'll be honest, but this is one of the limitations. But on the other hand, if you think about, if we assume that because we retrieve the memory using this script and then infuse midazolam, and that midazolam infusion prevented the reconsolidation of that memory, so basically helped erase it, and still we saw a different mechanism, so maybe the long-term effect of ketamine was still quite effective, right, on top of that. But this is one possible explanation, maybe, for the lack of difference in symptoms in both groups.
Because I don't see that midazolam was not working. Both of them worked, and I cannot assume that midazolam is a placebo.
Yeah, it's not placebo for sure. You cannot call midazolam a placebo, of course, because it's active, right? But we dealt with that. Again, this is a limitation, but I think it's limitation when you want to keep the participants blind. You have to give them something.
Yep.
So we try to kind of also comply with other works, like, I don't know if you're familiar with works of Diana Feder from NYU, from Mount Sinai. And she did some work about just infusion without psychotherapy on ketamine for PTSD patients. And in their work, midazolam was also the comparable group. But this is definitely something that we should all definitely add another group that does not have as active ingredient as midazolam.
Or you probably have experience, or you can say something about just the therapy and not with medication, with the therapy, and we can compare with a true placebo that it's no chemical intervention. That's what I'm thinking.
Yeah, I agree. So that's the best situation is to have at least one other group which with just psychotherapy, but undergoes the same kind of procedure otherwise. And in my experience, and in again the experience that I had here, the therapy was very effective, and it might be possible that this is what kind of overshadowed the effects of ketamine, because basically we were not able to replicate what Feder found with ketamine and PTSD, and we believe that this is a good explanation for that.
Thank you.
Rupert, I think you also had a question. Actually, two.
So
yeah,
okay, yeah, go ahead.
you go ahead. I mean, can you give some examples?
Your accent is better than mine.
Can you give some examples from other spheres of how the synaptic alterations reduce white matter integrity? And also just to sort of say that language of reducing integrity doesn't sound very attractive.
Yeah, definitely. So I try to kind of to be as close to the data as possible, and what we cannot really kind of measure white matter. We measure some kind of a proxy of the white matter, and that's why I use the white matter integrity. But generally, it's supposed to be a relatively good proxy of white matter, and in a study. And we discuss it a bit also in our paper, but there is a study that was done on animals in which ketamine was infused, and they kind of looked at the changes in neurons themselves, and what they saw is in a general way, I would say some kind of reorganization. So they didn't only see synaptogenesis or proliferation. They also saw some dendritic, let's say, reduced dendritic density and stuff like that. So those might explain or be aligned with the results that we saw. If you want, I can link to the paper we kind of mentioned in our work that kind of report that findings. Yeah, I'll look it up soon enough and I'll upload it to the chat as well.
I've always had this very naive sort of view that ketamine somehow promotes dendritic outgrowth, dendritic spine outgrowth, and that then provides the possibility of new connections. But you seem to be saying that the amount of the sort of dendritic outgrowth reduces. Have I got that right?
So so there are a lot of work by Alex Kwan, who was previously at Yale but moved recently, and he kind of discussed it quite a lot, and is doing a really interesting work mostly on mice. And what he shows is that this idea is a bit more complicated than we wanted to think. So while ketamine promotes some growth in specific locations, it also promotes a bit more of a change. So some death of, well, not of a cell, but of the dendritic spines, stuff like that. Yeah, I'll just add on top of that the general idea also that we have is that more connectivity should be good. And what I'm trying to actually portray is that it's not always exactly the case. But again, yeah, it's still a work in progress, I would say.
And presumably what you'd like to be able to show is somehow that the structural correlates of the sort of rumination that accompanies PTSD is what's disrupted.
Mm-hmm.
But that's obviously for the future.
Yeah. You use the word rumination that accommodates PTSD, and it opens up a big, at least in our group, we have a lot of discussions about maybe one of the reasons treatment doesn't work for everyone is that some people have the rumination part of PTSD is more more emphasized compared to others. Was the more fearful reaction part more emphasized? And yeah.
So I suppose that links in with my second question, which is, do your outcome measures? I mean, I'm not a PTSDologist, but do the outcome measures assess the intensity of the memory of the script, or just the emotional reaction to them, which I suppose is sort of similar to what you've just been talking about?
That's a great question, and I am unfortunately no. The answer is no, we didn't. But this is an extremely important comment on our future work, because we can even like in a different study when we tested neurofeedback with PTSD, we actually asked them at the end of each session how stressful they feel, like from 1 to 10 on a scale, like while they're lying in the magnet. So then we have some kind of manipulation. Yeah, I agree. It's extremely good comment, and we should imply that, use that in our future study.
And you don't have any anecdotal information about what the
Oh, I have plenty. So we know for sure that the people were very provoked by the scripts. Definitely. We used similar technique in the neurofeedback study, and there's at least once we had to stop the scanning because the patient was too overwhelmed. That's why, like, I was the clinical on-call on those studies, of course, because we knew that this situation can happen. In the ketamine study, we didn't stop the scan for anyone, but definitely they were extremely provoked by the script. And also, mind you, it's the first time they hear it like that. So they discuss it with the clinician beforehand, and they know they're going to hear that. But it's the first time they hear it once they're in the magnet. So yes, it's very emotional and provoking.
Do any of them say anything about the effect of the drugs? You know, anecdotally,
Anecdotally, so some were when they were so first when we infused the ketamine for almost all of the patients while they're in the magnet. So we also have kind of the functional MRI of during the infusion of the ketamine, which takes 40 minutes, and we try to show something with that as well now. And then they go out of the room with, we cover their eyes and stuff, because some are a bit high at that situation. Most are a tad dissociative, not extremely, but you can see they are affected by the drug, although it's on a sub-anesthetic dosage. And for most, it takes about more than an hour to fully recover. So what we do is we take them to another room, and the psychiatrist kind of checks in within a few minutes, every few minutes, to see what's going on. And once she or he sees that they are kind of returning to us, they start to question them about their current state. So for some, it took like an hour. For some, it took 90 minutes or so, but that's approximately the time. Some people thought that this is what actually helped them. So what really kind of helped them. Others.
You mean the ketamine or the questioning?
The ketamine itself.
Okay.
So even when you talk with them day later, or even kind of in the follow-up sessions, they do seem to say that the ketamine is the thing that kind of really helped them, but they were blind, so they don't necessarily know. Yeah.
It's always difficult to keep the blind, right, in a ketamine study, I guess. But
yeah, as long as they are naive to ketamine, if they didn't try ketamine itself, so you don't know exactly what to expect. I guess midazolam or some other thing that makes you a bit kind of changes your perception a bit could be okay.
and or just thinking back the data you presented, right? So I guess your main interest was the neural connectivity during the traumatic re-evocation. That I guess was just like they were listening, right, to the event while they were in MRI. And did you provide like any? Well, I have a couple of questions. Did you provide any instruction like to them prior, like for example, to keep their eyes open or closed, or try like to relive the example, like sort of like making this revocation as strong as possible? And my second question was like, did you just then compare the trauma, the MRI from the trauma script between groups, or did you contrast it, for example, with the more relaxed memories that you also collected, or with the sad one?
Yes, so we contrast it with more relaxed memory. We all in this paper we also show that we did the same thing with the sad memories. So sad contrasted with the relaxed, and we don't see those changes and we show those differences. I would tell you that we kind of moved back and forth. What should we use? The trauma versus relaxed, or the trauma versus sad? Because the general concept that we are trying to portray theoretically or clinically is that a traumatic memory, what we want it to be eventually, is more similar to a sad memory, because we don't want to erase the memory, right? It's a very sad story, but we want it to be, well, the presentation of it in the brain, or the way the participant, the patient perceives it, is as a sad, very sad memory. So more coherent, less fragmented, like traumatic memory. So we eventually decided to go with this, but I kind of ran back and forth with some network analysis and other stuff and in those analysis, we do see some, I would say, hint toward this theory that the traumatic network kind of changes following the treatment and becomes a bit more similar to the SAND network. But yeah, of course, they were contrasted otherwise. It's very problematic.
And I think we have another question in the chat, but for the traumatic one, did you use like sort of the index trauma, like same one that we may think was have like being at the source of their PTSD, or could be any, because sometimes, you know, there are multiple trauma in a life of a PTSD patient, unfortunately.
Yeah, of course. So again, you have great questions, and because each of them we kind of discussed quite a while. The simple answer is we used index trauma for the traumatic script. The not simple answer is that I had at least one participant that during the actual psychotherapy was done by me or Professor Harpas-Rotem, and during the life history kind of session before the beginning of the treatment itself, I discovered that they had a previous trauma that for me seemed to be more, I don't know, how would I put it? Better to focus on. Yeah, more, yeah. It's like the idea is we have very short period of time. We want to focus on something that's that will create a change. So we want to focus on the more on the kind of original as possible trauma. Let's call it like that. So in that case, that participant, I worked with her on in the psychotherapy sessions on the trauma that she was not scripted on, basically. Right, but it still worked. So, but most of, like, if not other than her, I think others were scripted on the index trauma. Yeah.
Thank you. I think we have a question from Avinash, if I pronounce the name correctly, is in the chat. Basically is asking, is the ERP post-ketamine needed? Does it add to ketamine, or is ketamine alone sufficient? In other words, if the patients just heard the script prior to every ketamine treatment for 4 weeks, could one see similar effects?
Yeah, again, these are questions that we ask ourselves, because we say, okay, so what happened here? Is the a mechanistic effect that we found was basically just because we kind of retrieved the memory while they're in the magnet listening to the script, and then infused with ketamine, so block the reconsolidation, and that was enough or not? And unfortunately, I am unable to answer that question. Of course, I would guess that it's both. I would guess that people who have the, let's say, the procedure proposed here by Avinash will also improve, at least to some extent, but this is again something that we have to test.
Okay. Well, I think we are approaching the end of our time together, so I don't know if anybody else has some extra question, but if not, just want to say like a huge thank you for Or for coming over and presenting his data. Sebastian Dierda, we're looking forward to the next study coming out from your work, and good luck with that. It really takes a village.
Thank you very much. It was a pleasure being here.
Thank you, everybody, and I guess we'll see you in 2 weeks.
Can I just make an announcement that just for those of you that were looking forward to our conference in September, it's been postponed. So we're going to have the conference from the ketamine conference in Oxford is now going to be 25th to the 27th of March next year. So I'm very sorry if that disrupts anybody's plans, but we just felt that was going to be a better time for quite a number of reasons, not least that Sarah will be able to join us then. So yeah, thank you very much.